All right, guys, it's that time of year when we begin to review for the AP Calc exam. This titled PowerPoint entitled Stuff You Must Know Cold for the AP Calculus exam. Remember, they do not give you a formula sheet for the AP Calculus exam, so they're not going to give you a list with all the different theorems you have to know, with the differentiation rules or the integration rules or anything like that. Not going to give them to you. Got to know them. Okay, as it says here, I didn't make this PowerPoint. This guy, Sean Bird, did. I found this online, and I just updated it for our purposes of this video. So to start off, let's review a little bit about curve sketching and analysis. So y equals f of x must be continuous at each critical point. What equals 0 or undefined? Right, the derivative has to be equal to 0 or undefined. Don't forget to check your endpoints. And a local minimum occurs when the derivative goes from positive to negative, or negative undefined positive. Or the second derivative test is the second derivative is positive at the critical number, implies that you have a local minimum. Okay, a local max is when the derivative goes from positive to negative, or the second derivative test says that the second derivative has to be negative for a local max to occur. Remember, all critical points occur when the derivative is 0 or undefined, but unless the derivative changes sign as the value passes over that critical point, it's not necessarily a max or a min. Okay. Point of inflection is the x value at which concavity changes. Same thing. Points of inflection always occur at points when the derivative or the second derivative is 0. But just because the second derivative is 0 does not imply you have a point of inflection. The second derivative must change sign. Okay, so the second derivative either goes from positive to negative or negative to positive. So here's some basic differentiation rules. The derivative of x to the n is n x to the n minus 1. Bring the exponent down, subtract 1 for the new exponent. Derivative of sine, cosine. Derivative of cosine, negative sine. Derivative of tangent, secant squared. Derivative of cotangent, negative cosecant squared. Derivative of secant, secant tangent. Derivative of cosecant, negative cosecant cotangent. Let me pause right here. Remember, for the basic derivative rules, if you're taking the derivative of something that starts with a cosine, cotangent, cosecant, the answer starts with a negative. Derivative of natural log u is u prime over u, or 1 over u times the derivative of u. The derivative of e to the u is itself times the derivative of the exponent. So e to the u, u prime, or u prime e to the u, however you want to think of it. Okay, how about some basic antiderivatives? Well, the antiderivative of x to the n is x to the n times 1 over n, or x to the n plus 1 times 1 over x, 1 over n plus 1. Really botched that one up, sorry about that. Derivative of sine is cosine, so the antiderivative of cosine is sine. Now, since the derivative of cosine is negative sine, the antiderivative of sine is negative cosine. So if your antidifferentiating and your answer starts with the answer should also start with a negative. So the integral of secant squared is tangent. The integral of cosecant squared would end up being negative cotangent. The integral of secant tangent would be secant, and the antiderivative of cosecant cotangent would be negative cosecant x. So if you have something of the form u prime over u, its antiderivative is natural log u. And if you have something of the form e to the u times the derivative of u, then its antiderivative is e to the u. As always, don't forget your plus c. Some more handy integrals. If you have the integral of a times x to the n, it's a over n plus 1 times x to the n plus 1. Don't forget your plus c. Okay, the integral of tangent. Remember, you can rewrite tangent as sine over cosine and apply the rule, the natural log rule, which it's a natural log of absolute value secant x plus c. Also, you could write it as negative natural log cosine. How'd they get that? Remember, secant is 1 over cosine. And if you write 1 over cosine as cosine x quantity to the negative 1, then use the power of logs, or the power property for logs, to bring the negative out front. Okay? So that's how you could do that. I've seen both of these on practice exams for AP Calculus. All right, so make sure that you're able to be familiar with manipulating answers to get equivalent forms for their answers. The integral of secant, we talked about this, is an absolute natural log absolute value secant x plus tangent x plus c. Okay, some more derivatives. The derivative of sine inverse is 1 over square root 1 minus u squared times the derivative of u. Cosine inverse is just the opposite of that. Tangent inverse, the derivative is 1 over 1 plus x squared. And cosine inverse is, or cotangent inverse is the opposite of that. Secant inverse is 1 over absolute value x square root x squared minus 1. Cosecant is just the opposite of that. Derivative of a to the x is itself times natural log of the base. And derivative of log base a of x is 1 over x times natural log of a. Okay. Now, for the derivatives of trigonometric inverse functions, you really only need to memorize sine, tangent, and secant, and just remember that the co-functions just have the negative of those derivatives. Okay, remember, change of base formula, you can write log base a of x as natural log of x over natural log of a, and that's pretty much how we got the differentiation formula for the log base a of x. All right, we also talked about some additional differentiation rules, namely the chain rule, or the inside-outside rule. So if you have f of u, it's the derivative of the outside with the inside still there times the derivative of the inside. Or if you have dy dx, it's dy du times du dx. Derivative of y with respect to u, which would be this part, times the derivative of u with respect to x, right there. Product rule uv, so it's the derivative of the first times the second plus the second, or the first times the derivative of the second. Okay, since it's multiplication and addition, it really doesn't matter which order you do it in, as long as each term has the derivative of one and the original of the other, and then the second term is the flip-flop of that. Okay, quotient rule, however, does matter. You have to have the derivative of the top times the bottom minus the bottom times the derivative of the top all over the bottom squared. Two biggest mistakes I see with that is they reverse the order of differentiation in the numerator and or forget the whole entire denominator. Lots of times people just think the quotient rule is the same as the product rule, you just subtract. Not true. Same idea, but you just have to subtract and divide by the denominator squared. All right, the fundamental theorem of calculus says that the definite integral of f of x dx is equal to the antiderivative evaluated at b subtracted by the antiderivative evaluated at a. So you basically anti-differentiate, plug in the upper and lower limits, and subtract those. And this is just basically saying that capital F has a derivative that is equal to the integrand. All right. Second part of the fundamental theorem of calculus says that when you differentiate an integral, you get the original integrand with the limits substituted. So if you anti-differentiated this, you'd get capital F of t, then you plug in b of x and a of x, so you'd have capital F of b of x minus capital F of a of x. But then if you differentiated it, you'd have to use the chain rule, and the derivative of capital F would be lowercase f, right here, but then it'd be evaluated at b of x, and then you'd have to, by the chain rule, you'd have to multiply by the derivative of the inside. Then the lower limit, if you evaluated it at a of x, if it was just a number, the derivative of just the number would be 0. But if it's a function you're evaluating it at, it would be the derivative of capital F of a of x would be f of a of x times a prime of x. The intermediate value theorem says if the function f of x is continuous on a closed interval and y is any number between f of a and f of b, so the y values evaluated at the endpoints, then there exists at least one number c between a and b such that c, when evaluated in the function, produces a y value in between a and b, or f of a and f of b. Okay, so basically it says that if from a to b, the y values go from one point to another, then you can produce any of the y values in between there by selecting appropriate values appropriate values in between a and b on the interval. The mean value theorem says that if the function is continuous on the closed interval and differentiable on the open interval a to b, there's at least one number such that f prime of c equals f of b minus f of a all over b minus a. What's that basically saying? That's basically saying that the mean value theorem guarantees that the slope of the tangent line would be equal to the slope of the secant line through the endpoints for at least one value on the interval that's between the endpoints. Okay? All right, mean value theorem and Rolle's theorem. If a function f is continuous on a to b and the first derivative exists, then the slope of the tangent line is equal to the slope of the secant line for some number on that interval. Rolle's theorem just adds that if the endpoints are equivalent, then the derivative has to equal 0 for one number in between. So basically, if the a is here and the b is here, f of b equals f of a. So the function basically has to go up and come back down and pass through that point, or it has to go down and come back up, pass through that point. And if the function is differentiable in between there, it has to do it in a smooth manner, which means it has to have a turning point, and that turning point is where the derivative would be 0. The only special case is if you have a straight line that goes from a to b, in which case all the values would have a derivative of 0 because you'd have a horizontal line and the slope of a horizontal line is 0. Alrighty. So now we'll talk about approximation methods for integration. We did the trapezoid rule, which you can memorize this formula, but I basically just remember that the trapezoid rule is the average of the left-hand endpoint method and the right-hand endpoint method. We are not doing Simpson's rule. Simpson's rule is not tested on the AP exam. We didn't go over it during class, so you don't have to concern yourself with it here. Okay? Let me just click through that then. The theorem of mean value and average value theorem. So if the function is continuous on the closed interval and the first derivative exists on the open interval, then there exists one number on the interval such that f of c equals the definite integral of the function over the interval divided by the width of the interval. That basically is saying when you take the definite integral of a function, you're kind of like getting the area under the curve. When you divide by b minus a, you're dividing by the width. So it's kind of like you're doing area divided by width equals the average height. The average value theorem says that a function will attain its own average height at some point on the interval as long as the function is differentiable. So that f of c is the average value of the function on the interval. Solids of revolution. We learned about the disk method, the washer method, and the general method. We also talked about the shell method, but the shell method is not specifically tested on the AP Calculus exam, though you are allowed to use it. If you do it correctly, they will accept that as a correct solution path. So a disk method is when you rotate the region around and it forms a solid with no hole in it, you use the disk method. Basically, if you take a slice, it's a circle. What you do is you get the area formula of a circle and integrate it. The area is pi r squared, and then you integrate it over the interval. Washer method, same thing, but with the washer method, when you rotate the region, it's a circle with a hole in it, the cross section. So you do the area of the big circle minus the area of the little circle. Now, I will tell you, here, the most common mistake I see is that instead of doing pi big R squared minus little r squared, they do pi quantity big R minus little r quantity squared. Okay? No, you don't subtract the radius, the radii, and then square it. you square the radii and then subtract them, because you have to think of it as the area of the big circle minus the area of the little circle. So to get the area of the big circle, you do pi big R squared, little circle would be pi little r squared. General volume formula is, in general, whatever the area of a cross section is, you integrate it over the interval to get the volume. I saw a problem once that they gave students, and they told students what the area formula was for the cross section, but didn't tell them what the shape of the cross section was. And that sometimes messes people up. But if you know, basically, you use the shape of the cross section to get the area formula. But if you know the area formula and don't know the shape of the cross section, the shape of the cross section is irrelevant, because once you have the area formula of the cross section, you just simply integrate it over the interval. Okay? So if you don't know the shape of the cross section, but they tell you the area formula of it, you're good to go. Okay, but that's just a mental leap that some people sometimes have a hard time with. We didn't talk about arc length because that's a BC topic. Distance, velocity, and acceleration. You have to remember that velocity is the derivative of position, and acceleration is the derivative of velocity, or the second derivative of position. There is a distinction and a difference between displacement and distance traveled. Displacement, you have to integrate the velocity over the time interval. Okay? Don't integrate the position function. I've seen questions where they gave the position function and asked for the displacement, and students integrated the position function. Okay? Really, if they give you the position function, all you have to do is evaluate it at the beginning and the end and subtract, and that gives you displacement. Just think about it. If you integrate velocity, you get the position function, and if you plug in the final and initial position, or times, you get the final and initial position. When you subtract, you get displacement. So displacement basically is how far you are from where you started. And when you integrate velocity over the interval, that's what it gives you. Distance is how many steps it took you to get there. Okay, now this square root thing, we didn't talk about that. You don't have to worry about that. That's a BC topic. But distance, you have to integrate the absolute value of the velocity, because what happens is sometimes you could be moving forward and backward, and your velocity could be positive or negative. Displacement cancels those out, and so sometimes your displacement might be 0, but your distance traveled might be 1,500, because if your displacement zeroed, you just stopped where you started, but you may have taken 1,500 steps to do it. So when you integrate velocity, it counts everything as positive steps, and therefore you get the correct answer. Okay? So at the end of the day, to get displacement, you integrate velocity over the interval. To get total distance traveled, you integrate the absolute value of the velocity over the interval. Okay? Remember, speed is the absolute value of velocity. Don't worry about this square root thing. Okay? So I've seen questions where they ask about the speed, but the velocity comes out to be negative, and that would be the incorrect answer. Okay? You don't need to know about vectors. We didn't talk about vectors. Average velocity, you just do final minus initial position divided by the total time it took to do it. Okay? So it's basically change in x over change in y. Average velocity is the same exact calculations as you would to get just regular old slope. Okay? Here's a chart with some common values of trig functions. So I'm just going to click through this to show them to you. And here we go. You don't need to know these 37, 53 degrees, the 3/5, 4/5. That's not going to be on there. But you do want to know all the first quadrant angles for sine, cosine, and tangent. I've seen questions on the non-calculator portion where they've asked you to evaluate trig functions. So, for example, you want to know that sine of pi over 6 is 1/2. And again, typically, unless they state that the problem is in degrees, it's understood to be in radians. Okay? So make sure your calculator is in radian mode before you try to do trig problems, unless it specifically states degrees. Okay? So here's all of the values, and make sure you know all of them. Again, you don't need to know 37 or 53 degrees. All right? Now, some trig identities. They don't specifically test the trig identities, though if you know them, sometimes they help with a problem or two. The double angle identity says that sine of 2x equals 2 sine x cosine x. So before you knew the chain rule, if you had to take the derivative of sine 2x, you couldn't do it. But if you rewrote it as 2 sine x cosine x, you could just use the product rule to differentiate. Now, there are a couple identities for cosine of 2x. You could think of it as cosine squared minus sine squared, or 1 minus 2 sine squared. Whichever one would be more to your advantage, you could use. Also, it's 1/2 1 plus cosine 2x. Cosine squared is also equal to 1/2 1 plus cosine of 2x. Sine squared is equal to 1/2 times 1 plus cosine 2x. And these are power reducing formulas. In other words, you could take the power, you could simplify cosine squared to get it without a power. And sometimes that's advantageous. All right, the Pythagorean identity says that sine squared plus cosine squared equals 1. And if you have ones with tangent, secant, cosecant, cotangent, you could just either divide everything by cosine squared x to get the one that involves tangent, because you would get sine squared over cosine. Or if you want the one that involves cotangent, you just divide everything by sine squared, and this middle one here would be cosine squared over sine squared, which would be cotangent squared. Okay? L'Hopital's rule says that if f of a over g of b equals 0 over 0, or infinity over infinity, you can take the derivative of the top and bottom and evaluate the limit. So this was very helpful for evaluating limits of indeterminate forms. Last year, this was not on the AP Calculus AB exam. It's a new topic they added this year. It used to be only on the BC exam, okay? But now they put it on the AB exam. So basically, if you get the indeterminate form from direct substitution of 0 over 0 or infinity over infinity, then you're trying to take the limit, and the limit of that ratio is equal to the limit of the ratio of the derivatives. Now, it's not the quotient rule. You just straight up do the derivative of the numerator over the derivative of the denominator. And if you still get an indeterminate form of 0 over 0 over or infinity over infinity, then you can apply L'Hopital's rule again. It also works if one or both of the infinities is negative, okay? But you have to have 0 over 0 or infinity over infinity. Okay, so there's two things here. Let me back it up. Oops. Anyway, you can apply the L'Hopital's rule multiple times if you keep getting indeterminate forms. Now, if it's not in the form of a fraction, if you get 0 times infinity or 0 to the infinity power or something, or different indeterminate forms, you can algebraically manipulate the function in order to get it to be a ratio and then apply L'Hopital's rule to that. Okay, so we also did integration by parts, which basically is a reverse of the product rule. So if you have the integral of u dv, remember we set up the 4-part cross-section where you had u v minus the integral of v du. So if you were trying to do integral of natural log x, remember you use Lipit in order to make your determination for what the u should be. So in this case, the u would have to be ln x because there's no other term or factor in there. So Lipit stood for logarithm, inverse trig function, polynomial or algebraic functions, exponential functions, and trig functions. Okay, so u would be ln x and dv would be dx. And the reason we pick u in these orders is because these are typically easy to differentiate, but in the order that you pick them, they are increasingly, they're harder to anti-differentiate. So the u is ln x, the dv is dx. So you take the derivative of that, you get 1 over x dx. The antiderivative of this would be v, and then you multiply. U times v would be x ln x minus the integral of x times 1 over x dx. The x and 1 over x cancel, and you just get the integral of 1 dx, which would be minus x, because the antiderivative of 1 is x, plus c. All right, well, that's it, guys. I hope that review, I know that was a crash review, went pretty quick, but that's a review of all the basic stuff you're going to need to know for the AP Calculus exam, for doing the reviews that I have set up for you to do in the coming weeks, and also to be able to perform well on your final exam. So if you have any questions about particulars or specifics, please reach out to me, and good luck, guys.